All right, let's dive right in and talk about how to design modern data platforms that are genuinely ready for machine learning. We're going to explore how to get away from those clunky, inefficient setups and build something where ML is just a natural, built-in part of the whole system. So let's kick things off with a pretty tough question you should ask about your current setup. Does your machine learning feel like it was just, well, bolted on as an afterthought? For so many companies, this is the absolute reality. They're trying to jam these advanced ML projects onto data platforms that were never, ever designed for them. And the result? It's always the same story. Development is painfully slow. The data pipelines are so fragile they break if you look at them wrong. And the whole thing is just a total nightmare to maintain. And this slide just lays it all out, doesn't it? The contrast is so stark. On one side, you've got this constant battle of the bolted-on world. But on the other side, you have the promise of a system that's actually integrated. We're talking fast iteration, robust systems, and results you can actually trust. It's really the difference between fighting with your platform every single day and having a platform that's actively making your job easier. So the big question is, how do we make that leap? How do we get from that frustrating, brittle world on the left to that powerful, efficient one on the right? Well, it takes a fundamental change in how we think about our data architecture. And the whole thing really centers around one core idea, one key component, the feature store. Now, a feature store isn't just another database. It's so much more than that. Think of it more like a definitive central library for all the data signals, all the features that your models need to work. It's the one place that guarantees the exact same logic is used to create a feature for training your model and for using that model to make live predictions. It's the single source of truth. And what this gives you is this beautifully simple and elegant data flow. See, raw data comes in from all over the place, it gets processed and transformed into these high-quality, reusable features, and then, this is the magic part, the feature store takes over. It catalogs them, it versions them, and it serves them up reliably to any model at any time for any purpose. It's just clean, simple, and incredibly powerful. Okay, so let's dig a little deeper into how this kind of architecture solves one of the biggest headaches in production ML, bridging the gap between the two very different worlds our models have to live in. To really get why a feature store is such a game changer, you have to understand this duality. Your models are basically operating in two completely separate universes, and each one has wildly different rules and requirements. I mean, just look at this. The offline world where you train your models is all about historical accuracy. You're using these massive data sets, and jobs can take hours or even days to run. But then you flip over to the online world, inference, and it's a completely different ballgame. It's all about pure speed. You need to make a live prediction in milliseconds based on one single, fresh-off-the-press data point. This gap, this offline versus online divide, is where so many machine learning models go to die in production. Why? Because the features get calculated one way for training and a slightly different way for serving. That inconsistency is a silent killer for your model's performance. And this is the exact problem a feature store is built to solve, by serving both of these worlds from that single, unimpeachable source of truth. But here's the catch. This whole amazing architecture is only as good as the data that you're pumping through it. A feature store is a powerful tool, but it's not magic. It has to be built on a foundation of trust in your data. And that's the crucial point. Any modern data platform worth its salt has to be built on these three pillars. They are absolutely non-negotiable. First, you have to guarantee data quality so your models aren't learning from garbage. Second, you need crystal clear data lineage so you can trace any feature all the way back to its source. And third, you absolutely must have reproducibility so you can go back in time and recreate the exact data your model saw 6 months ago. Okay, so when you bring all of this together, you've got the feature store, you've bridged the offline-online gap, and you've built it all on a foundation of trust. What does that actually look like? What's the real payoff here? Let's use a classic example, a churn prediction model. In that old bolted-on world, trying to combine a customer's real-time clicks with their 6-month purchase history is just a recipe for disaster. But with an integrated platform, the feature store handles it seamlessly. It serves up the latest user activity from the online side and their long-term behavior from the offline side, all using the exact same definitions. And the result? A way more consistent, way more accurate, and way more timely prediction. And really, that's what this is all about. This is the core idea. We have to stop trying to force machine learning to fit our old, outdated data architectures. Instead, we need to start designing our data platforms from day one with machine learning in mind. It just makes the whole process easier, faster, and a whole lot more reliable. So I'll leave you with one final question to think about for your own systems. Is your data platform a true accelerator for your machine learning goals, or is it the biggest obstacle standing in your way? Because architecting for an ML-driven future really begins by answering that question honestly.